let's introduce something called standing waves. Like the name implies, they are standing still, or appear to be. Let's take a look at this and analyze this in more detail here. A standing wave, well, just like the previous sections discuss about reflection and transmission. Imagine I had two fixed ends here, so I'm just going to make two fixed ends, and there's a rope. And if I send a pulse along that rope, and it goes along, and it's going to hit that end, as you know, it comes along and it hits the end, and none of it will get transmitted because it's a fixed end, but it'll come back on this side. It'll come back inverted. Now this one will go along and hit here, and then come back upright, inverted, upright, inverted, and keep doing this over and over and over again. Well, if I make repeated pulses, what happens is that some of these, or these waves will, or these pulses will start interfering with each other. And if I continue doing this, it'll start interfering. And what it'll look like is you'll get some places where they'll be destructive, where these two would meet, and in places where they'll actually add up and it'll get constructive. It'll end up looking like this, and eventually you'll get a wave that kind of stands still. And if I just made one pulse, imagine a simple version, one pulse, and a fraction of a second later, it's going to come back on the other side, and it's going to go boom, 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 boom. What we call these sections right here is we call these nodes. Okay, and there's a node. These we call antinodes. And in fact, at any given moment, there can only be, well, in this case, there's one antinode, and of course it keeps fluctuating. Here there are two nodes. So there's always one more node than antinodes represented. This, by the way, is called the first harmonic. Okay, that's your first harmonic. And it looks something like this. And I can draw you the other ones. The other ones would look, so if I go over here and draw you, well, you're going to get, that's n equals to 1. That's your first harmonic. N equal 2 would look actually like this. And so it's going to be like fluctuating like this. Okay, back and forth, back and forth, back and forth. Here there's 1, 2, and 3 nodes. Okay, there's your nodes. And of course here are your antinodes. And they just go back and forth, back and forth, back and forth. Of course these are always alternating. That's n equals 2. And n equals 3 may look something like this. And so forth. You'll notice a pattern here, okay, where this represents actually a half a wavelength. This represents a full wavelength. So this represents half lambda. This represents lambda. How many does this represent? Well, it actually ends up being 1.5 lambda. I'm going to write that as 3/2 lambda. And this continues on and on and on and on. There's an equation there that I gave you, okay, that basically says that the length of the rope is equal to n lambda divided by 2. What this means is that, well, if n equals 1, you'll notice that it equals half lambda. L, the length of the string, okay, will equal a half lambda. Okay, because this represents a half a wavelength, okay, or lambda divided by 2. This represents actually L, the length of this string. In other words, I'm just going to draw it down here. There's the length of this string. The length of the string would actually be lambda here. And if I plug it into here, I'm going to get 2 times lambda divided by 2, and that means that L will equal lambda, which it does. Here, you'll notice that if I write 3 in there, I'm going to get L is equal to 3 lambda over 2, in which case I get 3/2 lambda. If I want to figure out, so the length of this string is actually 1.5 times the wavelength, which makes sense. You could do the reverse and figure out what lambda is for this case, and lambda would equal 2/3 L, which makes sense here because here's 1/3, 2/3, and there's 3/3, and the lambda will equal 2/3 of the length. Okay, so you can rearrange this. The other formula I showed you on there was essentially based on these two here, was this one, and again this just comes from V equals lambda F, where the frequency will equal V divided by lambda, and of course if I divide it by this, I end up getting that formula right here. So both these are very, very useful to work with in terms of just analyzing what are called standing waves.